Welcome. I'm going to be talking about Camera Match today, and that is originally was a third-party plugin that was developed by an architect and Vectorworks programmer, Matt Panzer. I think sometime around 2017 or so, uh, Camera Match was incorporated into Vectorworks. And at some point along the way, Matt started working for Vectorworks directly as well. And he's a really great source of really great tools and esoteric lore about all things Vectorworks and architecture. So he's helped develop some of the more recent sort of architectural advances in Vectorworks, like the graphic legend. He had a lot to do with that, and various door and window improvements, and so on and so forth. So Matt's great, and uh, this is a really pretty impressive tool for somebody to have developed on their own. But he's obviously uh, a good programmer in addition to being an architect. So the purpose of Camera Match is to take a Vectorworks model and incorporate it into a real life scene. So, for example, the example that I'm going to use today, this is a proposed 3-story ADU, which is behind an existing 1-story structure. And you can see that I've got a little Google map that I've just taken a screenshot and pasted on site uh, at the correct scale, more or less. We could certainly be more sophisticated if we needed to. And I've gone ahead and modeled very simplistically this existing house, and then this house in the front, and then just a piece of a building over here. So let me take you to the photos so you can see what's going on. So uh, here's the scene, one of the two scenes that we're going to incorporate our model into this scene. That's a view from the street in front. And then I also have a view from the alley. And so let me go ahead and do a split screen here. Wrong menu. There we go. Perfect. So here's a view of the photograph of the alley. And that's just a photo I took with my phone. And here we are in the model. So that alley view is, give us a slightly less pronounced projection here. There we go. So that alley view is, something like this. And you'll notice that I have this, I don't know if it's it's a floor. It's 12 feet tall. And that represents this part of the building right here. Let me just give ourselves a fat line weight. So I just kind of walked over and did an informal field measurement and measured that mass and just modeled it as a floor over here. So I didn't even bother modeling the entire building. I just needed a reference point. And you'll also notice that I have over on the right, I've got this utility pole, and the first 9 feet of it I've extruded and made a different color. And that represents this little pink ribbon here on the utility pole that is 9 feet off of the ground. So in other words, I've gone in and I've prepared some of the real world objects to help me scale them into the photograph. If that makes sense. And then the building in front was part of the submittal, and so I was able to get an accurate footprint for that. And then this house on the side, sort of estimated that from some observations. So not a super detailed model at all, but it's going to be good enough for our purposes. So,
Excuse me, Francois, did you place the ribbon there yourself for scale?
uh, I I personally did not place that ribbon, but somebody placed that ribbon there for scale. Yes,
Okay.
but I could have just, gone in and just measured the top of this sign, right, and then just given myself a little point of reference to uh, to be able to do that. I did look up in Austin anyway. You can't really read the number in this photograph, but you can see there's a little yellow tag here, and that's a serial number, and you can call Austin Energy. I know not everyone here is in Austin, and you can give them the serial number, and they will tell you what size pole that is. And in this case, it's a 45-foot pole. But if you look at the technical criteria manual from Austin Energy, you'll know that a 45-foot pole is not 45 feet above grade. The whole pole itself is 45 feet, and 8 feet of it are buried in the ground. Um, so don't go thinking that this dimension is 45 feet. It's, actually 37, give or take. So I also want to talk about these two photographs real quick. And the very first thing you need to do with camera match before you start using a photo is you want to correct the photo for any kind of lens distortion. So particularly with older digital cameras, like if I was still using my iPhone 7, there would be a little bit of barrel distortion in the camera image. And even a little bit of distortion is going to completely screw up camera match. So you want to make sure that you have corrected the image for any kind of distortion. What I mean by that is that you want straight lines to be straight and to not have any curvature to them. Now, it it turns out that this old building has a bit of an angle to it already, and that's fine. But we're going to be relying on some straight edges in the photograph in order to establish vanishing points for perspective. And so obviously, if the building has some distortion due to the camera, that is to say that the vanishing points are canted inward or outward from where they should be, then camera match is just not going to work. So to that end, I'm going to flip over here to a program called Affinity. So here's that first image that I showed you from the street. Can everybody see my screen with Affinity here? Should say Affinity Photo at the top. Everybody can see that. Great, thank you. So Affinity is essentially a Photoshop substitute. It's if I can go ahead and give it a plug. I don't remember how much it costs, but it's extremely reasonably priced. It's not a subscription. You buy it and you have it. I think it was like maybe $50 or something like that. I mean, maybe it was a little bit more. I don't recall, but it's really, if you're going to do any photo editing, it's trivial. It probably doesn't do everything that the most modern versions of Photoshop can do, but I really am not a Photoshop expert. So in terms of like being able to rescale and crop and touch up images and do all of the basic stuff, it's got a really robust suite of tools. So I'm using Affinity Photo. In this case, you can also use Photoshop, or there's other lens distortion correcting software here. And you can see what I've done in Affinity is I've gone to, let me go ahead and cancel this out. So I've gone over here to help, and after doing a little bit of research in their help menu, Affinity has something called a persona, which is just a series of uh, edits to an image, and there's a liquify, expert, tone mapping persona, but there's a develop persona. So I click on that, and it's sort of this mini environment within Affinity. And you can see that at the top here, it says it's an RGB, it's an ISO 50, the millimeter of the lens, the speed of the camera, and so forth. It gives me its pixel density, and it knows that it was taken with an iPhone 14, which is what I took this with. And you can see that over here, there's a little button that says lens correction. I'm going to deselect that, and you'll see what happens, which is pretty much nothing. Turns out the iPhone 14 camera, it works, the image works flat out just the way it is without any kind of correction. But just to be safe, I'll go ahead and click that. If it's a camera that it recognizes, Affinity will refer to its database of the amount of correction needed in order to undistort the image. And if you're using some exotic camera, or you've scanned an old photograph or whatever, and you don't know what the camera is that generated this image, then you can go ahead and manually correct it. But that's pretty tricky, and you can see what distortion is doing. So, if it weren't for the edges of the image, if it had this much distortion and you just saw the image as is, you might think, well, that's okay, you know. But unbeknownst to your eye, there's some curvature over here in these columns. You can see there's kind of a bit of a concave curvature here on the edge of the building, right? So you could manually adjust for distortion. I think it's safer just to use software that automatically does this and not rely on your sort of fallible vision. At least I'm not. So we're going to say that I went and corrected these images prior to using them for camera match. But again, it turns out with the iPhone 14, that's not actually necessary. But I would just go ahead, and any image that you use, go ahead and check it for distortion, even if you think that it's safe, just to make sure. So we'll assume that these are corrected images. Let me go back to Vectorworks, and it actually right now this image is just a photograph that I pasted in just for the sake of explaining all of this to you. I'm not actually going to use this photograph directly in Vectorworks. I'll show you how that works in a minute. So go ahead and delete that. So what camera match needs is it needs some point of reference so that it can line up your model with reality. And so if I go to my visualization menu, you can see that there is a camera match mask tool, and there's a shadow tool, right? We're not going to use those immediately. We'll get those in a minute. But there's also a camera match command. I don't remember where it is, so I'll just look up camera match. All right, and there it is. There's camera match. It's under view, right where you've expected it. And the first thing you're going to need to do in your actual model is place a reference. So I'll go ahead and do that. And I'm going to give it a name. I'll call it reference point street. Okay. And I'm going to click on an insertion point. Now, I've already picked a point, and in fact, I already have one here, but I'm just going to show you how that works. So let me go ahead and get rid of this split view because that's not really helping us anymore. Okay. So here's my camera match object. I've got an old one here. I'll go ahead and delete that. Let me go to top plan view. It's a little bit easier to do that. And I'm going to turn off that photograph for now. I don't actually need it. It just looks good. So I've placed it over here and it's rotated the wrong way. So I'm just going to use my rotate tool to snap to the edge of this wall and rotate it that way. So if I take an isometric view, let me go ahead and don't know where my attributes went, so I'll just hide them and then bring. Oh, there they are. So I'm just going to beef up the line weight on this thing just to make it a little bit easier for everybody to see it. So you can see that the camera match reference is has 3 axes. The blue is vertical, that's your Z, and then you've got a red and a green, 2 horizontal axes. And you want to place it on an orthogonal corner of a real object that is already in the photograph. This is why I modeled these buildings as crudely as I did. Even though they're quite crude, they're good enough for my current needs. I modeled them so that I would have a point of reference. And you can see that I've placed it not at the base of the building. And let's go over to the street view. You can see in this photograph, we've got this front porch. I've counted the steps. It's about 18 inches above the ground. And then tucked away behind this column, there's a piece of green trim. And so I've just placed it right here at the corner of the building and about 18 inches off the ground. Of course, I could be more precise, but I think you get the idea. So, so I now have this reference object in my model on a design layer, and it is oriented along some walls, and it's going to help me with sort of referencing this photograph with my model.
Francois, is there a reason you didn't use the more visible corner in the middle of the building? Do you need to be on the outside edge?
So I want to be someplace where I can see, it's a good question, Steve. I want to be someplace where I can see some vanishing points in 2 different directions, right? So for example, this corner out here would not be a great choice because I can only see the horizontal siding. I can't see the wall on the left side that's obscured by the building. This corner here could also be a good choice. But I kind of like this one because you can see that, as you know, grainy as it is, I've got this teardrop siding here that I can help establish some vanishing points.
I see.
Yeah, so a featureless stucco building is problematic. But yeah, there's any number of places that I could go ahead and place it. I'm more confident about this building because it shows up on my survey. This yellow house to the left, I modeled it just as a point of reference to kind of give me a reality check. but I don't have that actually surveyed, so I'm less confident about where that is in the real world relative to the proposed structure in the back. Yep, makes sense. All right, so let's go ahead and I'm over here on the design layer, and I'm just gonna, move this photograph off to the side. I don't really need it. Let me go back to my model. Okay, and I'm not gonna get too fussy here. I'm just gonna make a real rough approximation, just sort of eyeballing this perspective relative to my photograph. Again, doesn't have to be super exact. So I'll go ahead and hide this thing over here. And I'm going to go ahead and create a viewport. So view, create viewport. Viewports just like we know them. Don't need a drawing label for this. Don't think I care whether I have planar components or not. And let's just go ahead and we'll tinker with the scale because it's a perspective anyway. It doesn't really matter. So there's my viewport. That's good enough. Okay. And now I'm going to go inside the viewport annotations. Right. And back to my view menu, camera match. I'm going to place a camera match object. So the camera match object is what's kind of this device that is going to give me 3 sets of vanishing lines to construct a perspective and adjust the perspective of the viewport to line up with a photograph. So I'm going to import a new image. I'll go to my desktop and grab, I don't remember which one it is. I think it's 7.6. That doesn't really matter. No, I don't think that's it. It might be 7.8. No, I think 7.6 is right. Okay. So here's that photograph, and you can see it's huge, and that's okay. So I can I'm going to go ahead and change the line weight of the camera match object itself, so you can really see these vanishing lines. So maybe it would be actually useful here to go ahead and do multiple views. So you can see in my camera match reference, right? I've got a blue vertical line, I've got a green line to the left, and a red line to the right. And so those correspond to these inside the viewport. I want to pick 2 edges that are going to give me a vanishing point that's vertical. And I want 2 that are giving me a vanishing point to the right, that's the red, and 2 that are going to give me a vanishing point to the left, that's the green. Now, if I pick 2 lines that are nearly parallel, I've got a large margin of error. So I want to try to pick lines that are not visibly parallel. I'm going to start with the vertical because that's kind of the easiest. We can assume that all of our buildings are plumb. Of course, that's not always the case. So I'm going to start here and I'm going to move this point over here and move that point over there. And then I'm going to zoom in. And I'm suspending my snaps by holding down the tilde key. And I'm going to place that there. So, that's close, maybe not close enough. And then over on this building, I'm going to put one point here and another endpoint of that other line here. And I'm just going to assume that these windows are, again, as I said, plumb. And I'm just zooming in and suspending my snaps to make it easier to kind of place this where I want. If I'm off by even a fraction of a degree, it's really going to mess things up, right? So, whoops. So here we go. I've got my two vertical lines here that are establishing the vanishing point, and I don't know if you can see, but it looks like that vanishing point is up above, way high in the sky, not down below, and that kind of makes sense, right? You can see where the yellow house in the photograph appears to be ambered slightly inward. So I find it useful to make these vertical lines rather far apart if possible, and it's safe to use elements from other buildings other than if something that you've modeled, right? Like I didn't model this house with the portico in front here, except for that little extrusion in the back. But it's okay. I can go ahead and use that because vertical things tend to all be vertical. Now, I don't recommend that you choose a parking sign as one of your vertical elements to establish a vanishing point because, those can easily be crooked. And then I'm going to go ahead and let me turn this off because it's a little distracting. I'm going to establish my left hand vanishing points. And here I rather conveniently, this is a real world exercise. I didn't just pick this for the sake of today's discussion. You can see that it's kind of easy to inadvertently move the wrong point. So that's something you really want to be careful of. So I'm undoing, which takes a moment in camera match to undo. Come on. Do that again. Great. So you can see that L2, that's line L2, its endpoint is right at the endpoint of V1. So you want to be careful with what you're grabbing. Yeah, so grab V1. So I'm just going to move it off to the side and come back and correct it later. I'll grab L2 there. And so very conveniently, I've got this piece of siding. That's nice. And let me put this back where it goes. That looks about right. And sure enough, L1 is over here. So I'm just going to have to move these things aside, right? So you want to avoid having the endpoints of your blue, green, and red lines too close to each other because you'll always grab the wrong one. It's Murphy's Law. And so I'm going to go ahead and put that here. And it automatically, you don't need to worry about which way the arrow is pointing. It automatically will decide which way the vanishing point is based on whether these two green lines are converging or diverging. So I've got those, and now I need to get my little red lines in place. So I'll just come back and trace that here. I'm not, oh, there's the other one. It's right here. Yeah, there we go. So let's zoom in here. And this is some old siding. Hopefully it's relatively straight. You can see it's a bit wavy. So I might choose, for example, the bottom of that eave instead of a piece of siding, right? It's of course, that fascia's chipped away. Pretty sad shape there. So I might need to play with it. And then it's giving me this black line, which is my horizon line. So if I go to the object info palette, there's a couple of things. I can show the reference object. And I don't know why it's not showing it to me. Oh, that's the other thing I have to do is I have to take the reference object and I have to put it, it doesn't know, right? Vectorworks doesn't know, it can't read a photograph, right? So I'm actually going to move this R2 to a slightly different position. Well, this will work. I just have to be real careful to put the reference object right here at the corner, right there. And then what I need to do is I can turn off these control lines, right? That's what those are. I can show the reference object or not. I can show the preview object, which is this green and red sort of cube. But this looks all wrong because I haven't clicked on set view to match. So if I click on set view to match, it is going to suddenly show me my model in the photograph. And it's pretty clear that I am way, way off here, right? So let's go ahead and see. Ooh, let me see if I can undo. Undoing in camera match can be a little slow, so hesitant to do that. I know what I did wrong. I forgot, of course, an important step, which is to establish scale. So we'll let it finish undoing here if it will. I got a little ahead of myself, a little excited. Come on, I know you can do it. There we go. So, um, the key thing that I forgot to do is one of these 6 lines needs to have a real world dimension to it. Um, so, so that's very important. And I can choose which line I'm going to give a real world dimension to. L1, L2, R1, R2, V1, V2. The V's are obviously the blue, the L's are the greens, and the R's are the reds, right? For lighting, right? So might need to go back to my model here. Go back to my model, and I'm just going to grab a rectangle and go to screen plane and just trace over this wall, which it did not do. Let's try that again. So according to my model, this rectangle is 12 foot 5.5, give or take. Okay, so that's how long this this face is. So I'm going to adjust L2 here. I'm going to extend it right to the trim, and I'm going to extend it right to the corner. So it's going from outside of trim to outside of trim. And then in the object info palette, the measured line isn't going to be L1, it's going to be L2. And I'm going to set that as I think I said 12 foot 5.5. Okay. And I suspect, judging from this preview, so let's go back to our view pane, multiple view pane. So this back wall here, from here to here, that's 11 foot 8 or so. So I'm going to click in the object info palette on the preview object setting. The preview object is this translucent green and red, these two planes. And I'm not going to constrain it to a cube. I'll make the left pane gosh, did I say 11 foot 8? 10 foot 8? I think I said 11 foot 8. And I'll make it 8 feet high. So this is telling me that I'm way off on my perspective here. So because really that green face should pretty much be mapped onto this back wall here. So I really have to be extremely careful to make sure that all of these lines are really spot on. So here, of course, again, I'm relying on siding, which may not be, perfectly dead level, but I might need to nudge this down by a pixel. That might not be enough. Again, I'm suspending my snaps. And you can see just that one little, oh, hi cat. Yeah, right. You can see just that one little tiny adjustment to that L2 line made a huge difference in the projection of this um, preview object, right? It's already, I mean, it's not perfect, but it's a lot closer than it was. And so once again, I'm going to zoom in over here, make sure I'm, right here on the middle of that line. Maybe this needs to come down just a tiny smidge. But I suspect what's really throwing me off are these right-hand lines. So let's pick a different reference point. I'm going to go up here and then go here. Maybe that little trim board on the fascia is a little more reliable, though, as curvy as that is, maybe not. Maybe I'd be better off, picking the top of the wall. That little error statement that popped up is because instead of grabbing the endpoint of that line, I picked up the entire camera match object, and that's a no-no. It's not really movable. And so maybe I'll pick this line here. Yeah, no, that made things worse. So maybe my problem is my vertical vanishing point. Yeah, that's much better. So I can, I'm going to need to keep fiddling with that and really try hard to find some lines that are legible so that I can be tracing over the photograph appropriately. Maybe I'll choose the top of this window here. And its siding. Of course, the funny thing about photographs is if you zoom in too close, you just see the pixels and your brain loses the image. Um, so I'm not going to waste a huge amount of our time just kind of going through and fiddling through all of these. But I think you get the idea that you have to be very careful and be thoughtful about the kind of photograph that you take and what angle you're taking from, that you've got, you know, uh, like brick coursing or some points of reference that you are confident are horizontal and that give you a line that you can sort of trace. You can then, once you've got it sort of close, you can fine tune your view with this button over here. Let's give that a try. Oh, cancel that. Let's go ahead and set the view to match. So it's still way off, but it's not as bad as it was before. And we can go ahead and fine tune our view. And so we can change the left or right vanishing points with these sliders. So I suspect that my right vanishing point is part of the problem here. So I can start to tweak it this way. I can also rotate my view. So maybe my camera wasn't quite straight. I can change my vertical vanishing point. reasonably confident about that. I kind of feel like the right vanishing point is the one that's more problematic. Let me get the object info palette out of the way.
Francois, could the
Yeah.
right vanishing points, the red ones, be put on the adjacent house if it's parallel? If the walls are
Yeah,
parallel?
but see, this is the problem. Is that's a really great question, Don. And the reason I'm not choosing an adjacent structure is these are old houses over on the east side, so I'm actually pretty confident that they are not parallel.
Got it.
Um, so so you can see that there's a certain amount of trial and error here. I'll just go ahead and exit the view, and then I'll up the viewport looks like a bit of a mess, and I'll go ahead and update it. And now it's sort of readjusted that. So, you know, I clearly have a lot more work to do here. You know, it looks like uh, my looks like I'm sort of too high and looking down. So let's go back to my um, uh, annotations. And I can fine tune my view, and I can change my field of view. Right, it's probably not going to help. I do think the problem is, yeah.
It seems like you're really far forward, Francois.
Yeah, and I might need to move back, right? I can move back. I can tilt left or right. It's not really doing anything for me. Um, that's too much. So, you know, the problem with fine tuning is that it's really intended for fine tuning. So I'll set the view to match. That'll undo all of the fine tuning that I've done. And really what I need to do is make sure that my lines are properly placed. And I think I probably could fiddle with it some more. I'm going to go ahead and show you what this looks like after I've actually, you know, done this properly and not on the fly. So here's the similar view. Actually, let me go ahead and give you the same view so you know I'm not fooling you. Yeah, there we go. So let's look at the annotations here. And you can see these are the these are my control lines. Yeah, so previously I picked the vertical trim of this window and the vertical trim of that window. I chose the horizontal of this window on the side rather than relying on. See, part of the problem over here is that I've got a lot of foreshortening on this wall. So relying on one edge is okay, but having you know, this horizontal element of the window is actually a little preferable. What you're seeing here is a camera match mask. So once I got everything adjusted, what I did is I turned off the layer that had the building in front because that model is just there for reference purposes. And then what I can do is establish a camera match mask. And so I can just draw. This is where holding down the B key is helpful for X-ray mode. And I can just also suspend my snaps. And so I can just draw a little mask here and mask out the part of my building in the back. And then I also have an anti-aliasing feature, so I can make that line blurry if I want of the mask. And then I can go ahead. So yeah, let's go back to my original model here. Let's go to here's my photo. All right, so I'll go ahead, instead of R2, I'll just pick this window here. Made some better choices last time. Yeah, I think I was a little worried about the neighboring two-story building just being a little shaky. Show my preview object. It's 11'8" by 8 feet tall, just like I said it. And you can see now that green plane, it's not quite, it's a little bit too long relative to the porch, right? It should probably end right about here instead of extending all the way to the window. But you can see that the perspective is a lot more reliable. And so now this is an appropriate time to sort of fine tune. Cancel that. Let me set the view to match. So now it'll sort of adjust the view. And now I can fine tune the view. And what I found in this particular instance was that sort of backing away, we're getting closer, was, helpful. Sometimes you run out of road. And then you go ahead and render the viewport. And rendering that as a wireframe. So you can see that green roof. That's another thing that's helpful, is to make your background render, your render initially in wireframe mode rather than shaded or final quality, because then you can see how your wireframe of your model is matching up to the photograph. So let's fine tune the view a little bit more. And Come up. Rotate it a little bit. You can see how my walls here are lining up. And I can also see how this structure is lining up with next door. It's getting a little closer, right? And then once I've sort of fine-tuned it, gotten it close enough, then I can switch my view from render to say shaded and render the viewport. Then what I did in this viewport is I just modeled everything that wasn't my building on the site layer and update that. And so now all of that goes away. We'll go back into the annotations. And now I'll go ahead and apply a mask. Again, suspending my snaps and X-ray mode. Very helpful. And then I can even reshape that mask with a regular reshape. Can add some points to it. Go. Give it a little bit of anti-aliasing so it's a little fuzzy. And if, I can have multiple masks if I want. So if I want this tree here to partly occlude the proposed building, I can do that. Give it a lot of anti-aliasing so it's real fuzzy, right? Add some points to it and so on. So again, just to kind of review real quick, you're going to want to model some adjacent real world structures as reference points. You'll want to select views in your photographs where you've got some relatively clean vanishing points that you can establish. Don't assume that adjacent buildings are necessarily parallel. And be sure and check your reference photograph to make sure that you don't have pin cushioning or barrel distortion due to your camera lens. It's a little bit of work, but there are times, when you're making a presentation to, historic landmark commission or architectural control committee or whatever, that it's a really invaluable tool. It's almost impossible to just eyeball your perspective and then copy it and somehow paste it into a photograph in Photoshop. That doesn't look realistic. Oh, and then another little tip is to figure out when you took the picture, if you can, and set your heliodon to the correct orientation and latitude and longitude and time of day and year, so that your model shadows match up with the real world shadows. That's a nice little touch to add at the end. So let's see. Anybody have any questions, comments?
That's why I thought I remember a demo about this early on where they, well, I guess put some points in the photograph and just sort of stretch the photograph onto the building model. Am I wrong about that?
That's the photograph onto the building. You mean like take a picture of an elevation of a building and apply it like a
Yeah, like
decal to your
you would be able to, you would have your model there, right? You have your 3D space all set up, and you could then bring this program in and let's say grab the underside of the eaves and just sort of pin the photograph, and it would stretch the photograph right to the model.
Not familiar with that. That's not ringing any bells.
That would seem to me to be, if that's a correct memory, it would seem to be a lot easier than trying to set up all these points. You know, you got some known points in the photograph. You already have a model that you sort of generated off your survey. So,
Yeah, that is, I don't know what that is, but that's not how Camera Match works. Camera Match adjusts your model to the photograph, not the other way around.
okay.
Other questions or thoughts?
If anybody, yeah.
I just wanted to say thanks for doing a live demo of it and not just like your final because I've also tried to use this tool and ran into very similar issues. So it's nice to see somebody who's versed in it hit the same roadblocks as me.
Yeah.
I gave up at some point because I had to move on to, I ended up like just didn't have the time to really learn the tool. So, but seeing this tells me that there is a light at the end of the tunnel if I was to stick with it if I needed to. So I really appreciate the demo.
Yeah, you're welcome, Bill. Well, I mean that is the that is the danger of live demos is they're usually a live demonstration of uh how I got it wrong. Um the I will say that it's I don't want to say that the Camera Match tool is finicky because that would imply that there's like some sort of design flaw or whatever. It's inherent to this kind of perspectival matching that just being off by a little bit, you can get really, really screwy results. And the other thing about Camera Match is that it, because of the nature of my work personally, this is a tool that when I need it, I really have to have it, but I only need it like once every 2 or 3 years. So, so then, I'll be like, okay, now how is this supposed to work? And, I'll email Matt who developed it. And, I don't want to suggest that everybody barrage him with stuff, but he's always super patient. Like the last time I was like, boy, this isn't working at all. And I forgot the very important step of, clicking on set view to match. Because if you don't do that, then, nothing lines up. So yeah, I appreciate your comment. And it's a tool that is really great, and it does require a certain amount of patience, and you have to be really meticulous. And probably the biggest pitfall is using a distorted image that you don't know is distorted, because you'll never be able to get it right,
Yeah.
because the vanishing points aren't parallel lines, they're curves.
Yeah, I mean, that was a part of the process I didn't even think about when I went for it. And so, like, you showing the part where you de-distorted the image was really important. I was like, oh, well, that makes sense why nothing ever lined up when I did it. Because,
Yeah.
It's a camera.
Yeah.
So,
yeah, you're trying to map a flat thing onto a spherical surface.
right.
Yeah,
Yeah,
yeah.
Francois, wouldn't a more two point perspective as opposed to, looking head on at the house give you greater ability to have it be, more accurate?
Yeah, yeah. No, this is why you can't just like snap a picture and just think, oh, well, this is the picture that I want to show in my presentation. You also have to be thinking in terms of, is this a picture that is conducive to, like, this is a hard one because there's so much foreshortening on the right side. The other image from the street that I showed that had the truck parked in front of it, that was a more oblique view of the primary structure in the middle, is a lot easier to deal with. So that's a great point, Don. I think if you have the luxury of not working from, say, a historical photograph, or, oh, God help you if you're trying to do this with Google Street View or something like that. You want to take a lot of pictures so that you can be selective about, which one is going to play well with camera match.
It seems like the longer your vanishing point lines are, potentially the more accurate they are.
Yeah,
Because if you're trying to do a little 3-foot section of wall versus a 30-foot section and know that that's
exactly.
a pretty straight line, I don't know. I haven't played with this that much.
No, you're absolutely right. And the other thing that I haven't mentioned, because this isn't something I've needed to do, is that camera match also works for interiors. That's a completely different point. When you place your camera match reference object, there's a button here for interior corner. And so you can, take a picture of an interior scene, like, say, an existing kitchen, and place one of these markers, and then set up a view of, say, a before and after, where you're matching your, kitchen remodel perspective exactly to a photograph. So I mean, the procedure is exactly the same. You need parallel lines to establish vanishing points. You need to, undistort the image if it's distorted, and so on and so forth. But there is that key component of having to click on interior corner.